Hello learners, welcome to Education Online. I'm your teacher, Madam Danny Susan. Today we're going to have algebraic fractions and equations. Algebraic fractions are the same, worked out as the same way as the ordinary simple vulgar fractions. Here we can simply cancel the numbers being given in the denominator and the numerator if they are matching. So we're going to have some few examples. So we are saying algebraic fractions can be simplified in the same way as ordinary vulgar fractions. That is simply by cancelling the denominator and the numerator if the letters are matching and can cancel both. So we are having our first example here. We are having our A as AB plus C out of BC. When given a number like this one, we are having AB plus C out of BC, but we said for us to easily divide by cancelling, we need to have a relationship within the denominator and the numerator. For example, what we have here, when you see AB is 1 plus C out of BC, BC is a number of its own, and we're having here AB and C. So we cannot easily cancel this one. This one is impossible because the denominator cannot make the two to be cancelled. For example, AB out of BC, then plus C out of BC. You can cancel, but you'll be left out with certain things. So in this case, it will be very hard for us to reduce this fraction by cancelling, as we said. So in this case, we are going to say that it is not possible. This cannot be simplified further. So let's have the second example, which is going to be AB plus, this is still the same one. When we have like AB plus C out of BC, you can come and divide this up and you'll be having AB out of BC plus C out of BC. Yes, we are having common things which can reduce here, but it will alter the meaning. That's why we say it cannot be simplified further. So even if you do it like this and reduce it, it will not give us the correct statement. So let's have another example. Have you seen here? We are not having an addition sign, but we are having multiplication. We are saying it's AB times C out of BC, implying when I multiply the numerator, I will get one whole number, which will be ABC, and when I divide with this, it will easily be cancelled. So here we are going to, after multiplying this, we shall have ABC out of BC. And when I have this BC is common to both, so you can easily cancel it and you'll be left with A, which is much easier. That's why I'm like, with this cancelling, it is not going to be easy, because we need a number that can completely cancel the denominator and also cancel what is in the numerator. But when you look at this, you cannot easily remove, because we do not have BC in the numerator. The B is on this side with AB and the C is here, so there is no way you can divide them separately. Even if I bring it here and I try to cancel this and this, I will still be left with something in the denominator, which is not what we want. When we talk about cancelling, simply you have to eliminate the denominator completely when you are dividing the two. So let's have the next example. Given our number, this will be Roman 3. We have x squared minus y squared out of x squared minus xy. Here we are now going to apply some of the things we've already learned. We are having difference of two squares, so we are going to express this numerator, which is going to be x plus y, and the next is going to be x minus y. This is the expression for the denominator. So let us also work out what is in the numerator. When you look at the numerator, x is common to both, so we are going to factor out x, and we shall be left with x here, and you'll also have minus y. When you open this bracket, you'll be in position to get the same expression given here. So when you look at this now in the denominator here, the two brackets, this one and that one, are matching, so you can easily eliminate this, because what we are having here, we are multiplying the numerator, and the same thing we are doing in the numerator. So when we have two brackets which are the same, we can easily cancel them. So now our final answer is going to be x plus y out of x. Don't go ahead and also cancel here. For you to cancel this x, unless the numerator, both values are having x. For example, if we were to have x plus xy, it would easily cancel. For you to eliminate or to cancel what is in the denominator, the two numbers in the numerator should divide equally what is in the denominator. So in this case, our answer is going to be left as x plus y out of x. Let's have example 2. Say simplify the following fractions. So we are having our first example as x squared plus x out of x squared plus 4x plus 3. We have been given an expression here, the first one and the second one, but when you look at the denominator, this is a quadratic expression. So we are going to simplify it. In order for us to, this will be x squared plus x out of, this is solution here, out of x squared plus 4x plus 3. So in this case, we've seen that our denominator is a quadratic expression. So we are first going to work out the denominator using the techniques we've been using while finding quadratic expressions. So in this case, if we are taking x squared plus 4x plus 3, what will be our product? what will be the sum? And what are those two numbers that when you multiply should give you the same product? And when you add the same two numbers, you'll be in position to get the sum. So in this case, our product will be 1 times 3, which is 3, and our sum will be 4. And what are these two numbers that when you multiply should give you 3 and when you add should give you 4? So we're going to have 1 and 3, because when you add 1 plus 3 will give you 4, and when you multiply 1 and 3 it will give you 3. So after, we're now going to have x squared plus x plus 3x plus 3. So when you group the two numbers, when you group the expressions, when you look at this, we are having x as being the common. So we factor it out and you'll be left with x plus 1 and 3x plus 2. 3 is common. You will have here 3 divided by 3 is 1. So this will be x plus 1. The two brackets are the same, so we shall have our first factor as x plus 3. And the second factor will be x plus 1. Here we've only dealt with the denominator. So we're now going to also work out the numerator. We are having, our numerator was x squared plus x. When you look at it, x is common, so we are going to factor out x. This is for the numerator. We bring our x outside and we shall be left with x divided by x is x plus 1. So if this is our numerator and this is what we've got in the denominator, we can now come back and write it as x into x plus 1 out of the denominator, which is x plus 3 into x plus 1. You can now see that the two brackets, one in the numerator and the other one in the denominator, are the same. So we can simply come and cancel this and that. After that, we shall be left with x out of x plus 3 as being our final answer. So if you are, when you look at the process of how we started, we were given two different expressions in the denominator and the numerator. We got to know that there is something unique about the two expressions. We worked them separately and independently in a way that when you look at the numerator, they share a common factor. And in that case, the common factor was x. We factored x outside and we are left with x plus 1 in the bracket. When you open this bracket, you'll be in position to get the same value from the start. It's the same thing we got with the denominator. We got to know that denominator is an expression which is a quadratic. So what we had to do is to work it out like how we factorize quadratic expressions. After simplifying it, we ended up having the two factors. So we came and wrote that the numerator, the new value after factorizing, and the second denominator, we also got two factors. After getting, we got to know that we have two common brackets, one in the numerator and the other is in the denominator. It was easy to cancel because both of them were the same, and this is multiplication, so removing it was easy. This cancelled with this and we're left with x out of x plus 3 as our final answer. So we're going to continue further with more examples on expressing the algebraic fractions. So we are saying our next example, simplify So we've been given two different fractions and we are supposed to simplify it, simplify the expression where possible. So we've been given this two different fractions we are adding, and both of them have separate denominators, and we're having a bracket here and also here. So there are two ways you can do this number. You can first open the brackets on the numerator and get the expressions before you go and find the denominator. I mean the LCM for the two fractions. Or you can find the LCM, then you multiply all at once. Okay, when given a number like this, first we are going to open the brackets of the numerator, then we get the final values before we go and get the LCM. So in this case, when you open this bracket, you're multiplying 2 by each and every number that is inside the bracket. So in this case, 2 times x will give us 2x. 2 times negative y will give you negative 2y. All this out of 5. Plus 3 times x will give you 3x. Plus 3 times 2 to give you 6y. All this out of 2. After finding this, now we are going to find the LCM for the two denominators. We are having 5 and 2. To get the LCM, we are going to look for multiples that can divide the 2. And here we are going to use 10. So we are going to have our LCM here as 10. 10 divided by 5 will give you 2. So we shall have 2 into the numerator, which is 2x minus 2y. Close bracket. 10 divided by 2 will give you 5. So we shall have plus 5 into 3x plus 6y. So we're there now. We're going to open our bracket, which is this. We are having 2 into 2x minus 2y plus 5 into that. We've now got a single denominator after finding the LCM to both 5 and 2. So in this case, after opening the bracket, we are going to say this 2 has to multiply each and everything that is inside the bracket independently. So in this case, we are saying 2 times 2 will give us 4x minus 2 times 2 to give us 4y plus, you put this in its own bracket, 5 times 3 will give you 15x. Then 5 times 6 will give you 30y. All this you write out of 10. We have these two brackets here, and we are having common terms that are sharing. So we can simply open the bracket and we collect the like terms. So in this case, when you open this bracket, we are going to collect the x's alone and the y's alone. We shall have here 4x plus 15x. Then we shall have minus 4y plus 30y. All this you write out of 10. So when you add 4 plus 15 will give you 19x. Then when you add negative 4 plus 30 will get positive 26y. All this out of 10. We are having 19, 4 plus 15 to give us 19, and this is 30 minus 4 to give us 26. So we are having 19x and we are having 26y out of 10. In this case, we only have a common number which can reduce 10 and 26, but we don't have any factor that can reduce 10 and 19, implying this is going to be our final answer, because we said for you to cancel a number, should cancel both. This same number should have a factor that divides here and there. For example, if we choose 2, we're supposed to divide all through the 3 numbers. But since this case we're having 19 which has no factor that can divide both 10 and 26, we leave this as our final answer. So we simply say therefore 2 into x minus y, all this out of 5 plus 3 into x plus 2y out of 2 gives us our final answer as 19 x plus 26y, all this out of 10. So that will be our final answer after working out that that fraction. Let's have an example 2 similar to this. That will be example B. We shall have x out of 2y plus x out of 2y minus x out of 4y. So when you have a number like this one, it's a fraction. So first thing we need to do is to find the LCM for the 3 fractions. In this case, when you look, we are having 2y, and 4y. So our LCM here will be 4y because 4 is a multiple of 2 and can easily divide all this here minus getting a remainder. So we come here and say our LCM is 4y. So we bring the 4y here. 4y divided by 2y will give you 2. The y will cancel. 4 divided by 2 is 2. Then you multiply it with the numerator, which will be 2x. 4y divided by 2y, the y will cancel. 4 divided by 2 will be 2. You multiply it by x to give you 2x minus 4y divided by 4y will give us 1. 1 times negative x will give us negative x. After getting this, you can see that all the values on the numerator are all values having x. It means they are common, they are like terms. So we're simply going to add them together and get a final answer for the numerator. So in this case, we are saying 2x plus 2x minus x. 2x plus 2x is the same as 4x minus x out of 4y. So 4x minus x, that is 3x out of 4y. And this will be our final answer after working out. When given a fraction like this one, there are 3 different fractions. We found the LCM. We use the LCM help us get the appropriate values after dividing LCM with what is this denominator. Then you multiply it with the numerator and we ended up with like terms. We added the like terms and we ended up with 3x out of 4y as being our final answer. So that is it with algebraic fractions. We are now going to have algebraic equations. We are saying an equation is a simpler statement in algebra which shows that the 2 given expressions are the same. So we're going to have an example of the equations which will show us the 2 given numbers are the same. So we're saying an equation is a statement in algebra simply saying that an equation is a statement in algebra which shows that the two given expressions are the same. So let's have an example to see what makes the two given expressions to be the same. Start by linear equations. Okay, when you look at these numbers, all of them are having one unknown in the expression. For example, the first one, we're having x plus 9 is equal to 10. Then we are having 3x plus 1 is equal to 2x. And lastly, we are having 2y plus 3 over 4 is equal to 3y minus 1. So when you look at an equation of this kind, they are called simple linear equations because they're having only one unknowns and they're easy one we are to solve them. For example, if you talk about the first equation, remember we are saying an equation is a statement in algebra which shows that the two given expressions are the same. So in this case, when we have a number like this, we are saying they are called a simple linear equation. If you take an example of this first one, to get the value of x, we simply need to collect the like terms. Take this 9 this side, and you know positive crossing an equal sign becomes a negative, then you can easily get the value of x without struggle. Let's have other examples. We are saying solve the following. So we are having our first example A as 5 into x minus 3 close bracket is equal to 3 into x minus 1. And our example B will be 5 over x plus 1 over 3 is equal to 8 over 9. So we start with solving the first example. Which says that is A 5 into x minus 3 is equal to 3 into x minus 1. First thing we need to do is to open the brackets so that we can see the like terms and we collect them accordingly. So when we open the bracket here, we're going to have 5 times x to give us 5x, 5 minus 3 to give us negative 15. Then 3 times x will give us 3x. 3 times 1 will give us minus 3. After having this, we can easily collect the like terms. Bring the unknowns together and also put the numbers together. So in this case, we are going to bring 3 this side and we shall have 5x minus 3x. When this 3x crosses the equal sign, it becomes a negative. Minus 15 is equal to 3x minus 3. This has crossed the equal sign. So now we are left with 5x minus 3x minus 15 plus 15 to give us negative 3 plus 15. So this has crossed the equal sign. Now we are having 5x minus 3x is equal to negative 3 plus 15. So we're now going to have 5x minus 3x to give us 2x equaling to negative 3 plus 15 is the same as 15 minus 3 to give us positive 12. But when you look at this, 2x and 12, it is divisible. But because we are looking for value of x, we are going to divide the coefficient of x on both sides. So we're now going to say it is 2x divided by 2 is equal to 12 out of 2. So finally our value of x will be 6. So after working out our expression being given, we've got to know that our final value of x is 6. To get a clear view, if you put 6 in these positions where we are having x in the expression, you realize that the answers are the same. For example, if we put 6 here, 6 minus 3 is 3. 3 times 5 is 15. When I put here 6 minus 1, that is 5. 5 times 3 is 15, implying the statement and the answer is correct. Let's also work out the second example, which is example B. It says 5 over x plus 1 over 3 is equal to 8 over 9. We are having fractions here. So we are having x, we are having 3, and we are having 9. We don't know what are the LCMs, but we need to find out. So in this case, we need to get the LCM of x, 3, and 9 so that it can help us to eliminate the denominators, okay? So in this case, we are going to have our LCM as, you know that LCM of 3, x, and 9, we are saying 9 not because 9 is a factor, I mean a multiple of 3 and even 9 itself. But we are having x here. Since x is a letter, it's not a number, our LCM should also carry that letter so that it can be easy. So in this case, our LCM is going to be 9x. Because we want to eliminate the letter from the denominator. So for us to have the LCM to reduce all the denominators, we need to have that x. So we are now going to multiply our LCM throughout with the fraction. We are having 5 over x times 9x. If you don't want to do it like this, you can also do it like the first way we did. We can try it. It's still the same. Then plus 1 out of 3 times 9x is equal to 8 over 9 times 9x. So when you have this, this x will go with this. This 3 will reduce this. You'll be left with 3. The 9 will reduce this. You'll be left with x. So we shall have 5 times 9 to give us 45 plus 3 times 1. But we are having x, so we shall have 3x is equal to 9 and 9 as divided. We are left with x. So 8 times x will give us 8x. I think it's now easy for us to collect the like terms. Now with this, we are going to take this the other side, so we shall have 45 plus 3x. The 3x was a positive, so we're going to subtract it on both sides. Minus 3x is equal to 8x minus 3x. So 45 will equal to 8 minus 3 is the same as 5x. We divide both sides by the coefficient of x, which is 5. Finally, we are saying 45 divided by 5 is 9. So therefore, our value of x will be 9 as required. So we said we were solving the equations being given, and we had 2 examples. We've seen how to work it out. When given 2 fractions, the first thing you need to start with is to find the LCM that can help you to reduce all the denominators. In this case, we multiplied each and every fraction by the LCM instead of like the first one we did, whereby we wrote the LCM and divided by each denominator. It's still the same. You choose what is simple to go with. Thank you for today. I remain your math teacher, Madam Danny Susan. We catch up next time. Keep it educational.